Hello everyone. Today let's talk about data types in Java. Today we will be covering data types, primitive data types of primitive data types, examples, and Unicode. So, data types specify the different sizes and values that can be stored in the variable. Since the data to be dealt with are of many types, a programming language must provide ways and facilities to handle all types of data. Java, like any other programming language, provides ways and facilities to handle different type of data by providing data types. Java data types are of two types: primitive and non-primitive data types. Non-primitive data types are also known as reference data types. These are constructed from primitive data types. Primitive data types comes as a part of programming language. Java provides eight primitive data types which are byte, short, int, long, float, double, char, boolean. Anything enclosed in single quotes represents character data. Numbers without fraction represents integer data. Numbers with fraction represents real data, and anything enclosed in double quotes represents a string. Reference data types, also known as non-primitive data types, these data types are classes, arrays, and interface, but their storage mechanism is different from primitive data types. We won't be talking much about primitive data types in this session. Now, here we can see the data types are of two types: primitive and non-primitive. And on and primitive is further classified into Boolean, char, byte, short, int, long, float, and double, while non-primitive data types are string, array, etc. Now, primitive data types. These are the fundamental data types offered by a programming language. These are the building blocks of data manipulation, and Java does not support unsigned data types. Only unsigned data types are those data types that only stores positive values. All numeric data types in Java can store both positive and negative values. There are eight types of primitive data types. I already told you: Boolean, byte, char, short, int, long, float, and double. Now, let's talk about Boolean data type. The Boolean data type is used to store only two possible values, true and false. A Boolean value can have two values, true and false. It is used to for simple flags like that check true false conditions. A Boolean data type specifies one bit of information. It can be either true or it can be either false. It is mostly used in logical conditions. Java reserves 8 bits but uses only 1 bit for Boolean data types. Here, in example, we can see that we are declaring a Boolean variable, Boolean 1 equals to false. Here, 1 is a variable name and false is the value, and Boolean is the data type. Now, these are all the data types with the default values and default size. Boolean. Java stores 8 bits for Boolean but uses only 1 bit, and its default value is false. Char, we can see that default size for char is 2 bytes, which means 16 bits. For byte, it is 1 byte, which means 8 bits. Short, 16. Int, 32 bits. Long, it is 8 into 8, 64 bits. Default values, as we can see here, for byte is 0, short is 0, int is 0, long is again 0, but to differentiate long from int, we are using a L. Here float is zero point 0.0 and double is 0.0. Here double has 64 bits again and float is having 16 bits. Now let's talk about byte data type. The byte data type is another example of primitive data type. It is an 8-bit signed two complements integer. Signed defines here that we can store negative and both positive values in byte data type. its value its value range lies between minus 128 to 127, including 127 and minus 128. Its minimum value is 128, minus 128, and maximum value is 127. Its default value is 0. Here we can see an example that byte A is 12 and byte B is 10. Okay, now let me show you something from an example. I'll be using an online compiler for this. Let's declare a byte variable a equals to 126, 1 less than its maximum limit, and let's print a here. A. Now let's increment the value of a by 1. Now let's again print this a, print ln a. Now it will reach the maximum value of 127. What happens if we again increment the value by 1? Now let's again print this thing called print ln a. Let's again increment the value by 1. Now let me just copy this. Now let's run this code and observe what's happening. Yes, uh, I'm okay. We can see that here 126 was printed as we initialized 126 to the A. Then we incremented the value of a by 1, so it changed to 127. Now, after incrementing the value, why this negative 128 came here? So, on reaching its maximum value and then again after incrementing the value of byte, it starts the loop again from its minimum value. So, after incrementing the value of 127 for a byte variable, it will go to the minus 128. And then after incrementing the value by 1, it is updated to minus 127 since minus 128 plus 1 is minus 127. So this is how byte works. Now what if we assign a value that is outside the range of a byte variable? Let's assign 300 to the variable, and then now running the code, it will give a compile time error since 300 is not in the range of byte, so it will be considered as an integer value. Now let's talk about short data type. Short data type is a 16-bit signed 2's complement integer. Here again it is a signed bit since every numeric data type in Java is a signed data type, which means it can store both positive and negative value. The range of short lies between minus 32768 to 32767 inclusive, and its minimum value here like we stated in range that minus 32,768 and maximum value is 32,767. Its default value is 0 and example is short s equals to 10,000 since it is smaller than 32,767, and for negative value we use minus 5,000 which is again greater than 32,000 minus 32,768. Now, integer data type. The int data type is 32-bit signed 2's complement integer. Its range lies from minus 2 to the power 31 to the plus 2 to the power 31 minus 1. Oh, this is a really a large number. Its minimum value is minus 2 to the power 31 and maximum value is 2 to the power 31 minus 1. Its default value is 0, and here we declare two integer variables as an example. Int a equals to 1 lakh and int b equals to minus 2 lakh, which is in the range. Now, let's talk about long data type. The long data type is a 64-bit 2's complement integer. Integer value which states that we can store decimal values in long and in short also and in byte. Its value lies between minus 2 to the power 63 to the minus 2 to the power 63 minus 1 inclusive. So its minimum value is minus 2 to the power 63 and maximum value is 2 to the power 63 minus 1, and its default value is 0. Example for long data types are long a equals to 1 lakh l to denote that this is a long number, long value, and long b equals to minus 2 lakh l. L again here denotes that this is a long number, not long but a long data type number. Now, float data type. The float data type is a signed precision, single precision 32-bit floating point. Here, Floating point shows that we can store decimal values in float data type. The range of float is unlimited. It is recommended to use float instead of double if you need to save memory in large arrays of floating point numbers. Yeah, we can also use short instead of int if we need to save memory. Uh, Likewise, we can use float instead of double to save memories in large arrays of floating point numbers. The float data type should never be used for precision values such as currency. Its default value is zero point zero f. For example, here f can be small or in uppercase, it doesn't really matter. And in example here we can see that float f1 equals to 234.5 f. Now, let's talk about double data type. The double data type is a double precision 64-bit floating point number. Its value is again unlimited. The double point data type is generally used for decimal values just like float. The double data type also should never be used for precision values such as currency. Its default value is 0.0d. Now, example here we can see that double d1 equals to 12.3. Here, if we are not using d, then it is considered as a double data type value. Now, let's talk about character literal. Char data type. The char data type is a single 16-bit Unicode character. Its value ranges from 0 to 65,535 inclusive. The character type is used to store characters. The character literal is one character enclosed in a single quotes. For example, A in single quotes. Java allows you to write certain non-graphic characters in character constraints. Non-graphic characters are those characters that cannot be typed directly from keyboard. Example: backspaces, tabs, carriage return, etc. These non-graphic characters can be represented by using escape sequences, and escape sequence is represented by a backslash followed by one or more characters. Here, we can see that this backslash UFFFF is a special character that we can't directly type from the keyboard. And this uses a backslash which represents that this uses an escape sequence. Now, let's talk about Unicode. Unicode is a universal international standard character encoding that is capable of representing most of the world's written language. Before Unicode, there were many language standards like ASCII, ISO 88591, KOI 8, GB 18030, or Big 5 for Chinese, and so on. There are many character codes before Unicode, but now we are using Unicode in Java. I hope all your concepts from today's class are clear. Thank you.